is worth our investment in time and resources, machinery, etc., engineering, and what makes that profitable for people to pay for that service. So certainly one of the things that we have in beta right now is a cloud storage service, and we can talk about it a little bit further on as we visit some of these areas. So like I said, the co-location, I don't know how many of you guys have started to think about or hear infrastructure as a service. Okay, so a lot of companies are finding that it's more predictable if they outsource their data centers, and the first step in that is co-location. We have SAS 70 data centers. In fact, like I said, we've got one down the street on William Street. I can't get into those locations. I think you can get into some of them. But it's certainly one of those things where you have controlled access and you have, we have 100% SLA. So we really focus a lot on the availability and reliability of the physical systems. And as I said, as we go in, some folks, and you start to see the route optimization piece, but some folks or enterprises have decided that for a variety of reasons, very similar to the argument for co-location, that they really want us to manage their switches, their hosts, their firewalls, and that it's not like it's impossible for even large enterprises to do, but it's just more convenient to have a set of folks to take care of that for them. It actually has really, I guess we've expanded, I don't know how many physical locations we have now, but they're quite large. In fact, one of the things that we had discovered was that we were sort of going about a plan where we rent space in somebody else's facility, but then provide the managed hosting. So it's much more profitable to actually own the data center itself rather than leasing the location. So we really started to move in that direction, and we'll continue to do so. And there again, the route optimization portion comes into play almost in all of our offerings. That whether it's a co-location facility or a managed hosting facility, that route optimization really plays a critical part. And right now, this is the place in the software that I'm working. We have a couple of major initiatives. So Nero is the route optimized IP, and now the effort is to put into place the things we need to have an IP version 6 offering. It sort of rose to everybody's mind when they handed out the last IPv4 block fairly recently. And we've got a lot of portions of the network that are enabled for IPv6. The network guys are way ahead of us, of course they have to be. But the ability to monitor, build the network topology, probe for round trip times, etc. We're actually building in IPv6 support here, for example. XIP, I don't know how many of you guys have done analysis of the TCP/IP stack. Anybody done one of those courses? Of course, there, if you have looked at that, then the ramp time that you might take for the protocol to converge to the appropriate window size is not always what we would hope. And so you can do some things in the TCP/IP stack to converge more quickly. We found that, yeah?
So did you add it like a new layer or just updated that layer?
Well, we've gone about it 2 or 3 different ways. In fact, so we put devices in front of a PNAP where we route traffic through a TCP optimized device. In fact, one of our products has that on both ends where it provides an accelerated tunnel between 2 points of presence. In fact, we have a patent that should be, closed any day. I think we talked with the examiner. And one of the XIP offerings that's happening right now is an asymmetric acceleration. So it turns out that if you're sitting on a host in the network and you're pushing the string to somebody else, it's actually that use case is amenable to this sort of optimization, particularly for transmitting large files or over high latency links. So an example would be game updates. If you're in Brazil and you're wanting the latest Call of Duty map or mod or whatever, and you've got to get it from a US server, then to push that large data set, that long distance, is very amenable to this. It's kind of astounding actually when you look at the rest. As I mentioned, CDN is performance optimized content delivery. Some of our new stuff there, we're doing HTML5, and in fact streaming in HTML5. So our Flash media servers also do some interesting streaming. Of course, we do the old style, what is it, RTMP. You know, so there's a variety of protocols. Now, in this world, there's also the transcoding problem, which is becoming more and more an issue. People want to do on-the-fly transcoding, say for iDevices. And as we move into the world where the proportion of viewers to publishers shifts, then that becomes more challenging in an interesting sort of systems way. Because you think about it, we were right here in Turner, CNN, you know, all these kind of broadcasting organizations. So there's a few of them, and then there's like Major League Baseball, you know, a whole bunch of viewers of any given game. Well, as we start to use iDevices and other devices for recording, in fact, like right now, we might be wanting to stream this. There might be some folks at another campus that would be interested in hearing the presentation, or maybe folks from our offices just a few blocks away. So, you know, in that case, we might have an increase in the number of people who want to publish live streaming content, but the proportion of people who are going to watch any given stream goes down, right? So, in that world, you have your iPhone, your iPad, your widescreen monitor, projection up on the screen maybe is high def. So you have a bunch of different formats or even bit rates, depending on what kind of connectivity to the network you have. So it's sort of an interesting area where you begin to do work in order to optimize the delivery of content in a global fashion. And there again, we pull forward the same kinds of advantages as before, because all these are layered in. You end up accruing those same advantages. So then this is directly on CDN. So really, we're doing the storage in terms of, so I'd already described the other device, so storage like storage area networks. You have these companies that have large amounts of content, and the reason that they don't want to serve it to all the people on the edges is the same reason it's hard to store. I mean, you have, for our whole site delivery, you have some sites with catalogs that may even have 1.5 million objects. Okay, if you think about an online catalog that somebody is going to serve over the internet, you have a tremendous number of individual objects. So even the problem of keeping, say, a storage area network that has installations across multiple continents. So if somebody uploads content to one of those sites, where does that update need to be propagated to? And so, for example, as before, we use our XIP acceleration to push content between our storage area networks. And in a similar fashion, we're working on the same thing in cloud, so that you might have a representation of your stored or persistent data that is globally replicated. So then, to go further into that, and this is where I have to be a little bit careful on how I speak to it. Almost everybody has a cloud these days. You know, is it Amazon? Is it Salesforce? Is it Google? Is it Microsoft? everybody's got a cloud. Well, we're in the business, so we have to have a cloud as well. So one of the things that we've thought about, even in IP delivery, is how to do it in a more intelligent fashion than the state of the practice. So in that world, there's a whole lot of things that we end up wanting to do in our cloud offering that makes it a premium service, that makes it a reason to fold it into the internet space rather than half a dozen other cloud providers. And in fact, it's almost a good time to talk about open source development. I don't know how many of you guys are active participants in open source projects. Internap, we go head over heels into them. Sometimes, much to Anna's dismay, maybe a little too quickly. So we use things like Zebra and Quagga, you know, for software routers. We use, what is it, the cloud, the storage providers. It was actually open sourced from Rackspace. Yeah, the OpenStack, right? So we take these, I had actually used Cassandra in several portions, and you know, you track for a long time while you're still on the trunk. You don't even have a stable release yet, you know. For example, we wanted a version of Cassandra, which is a distributed hash, sparse matrix. We wanted to be able to have dynamic schemas. If you're going to provide it as a service, it's one thing to use it, but if you provide it as a service, then you need to let someone else define the schema. And you don't want to have to restart the instances in order to provide that dynamic schema definition as a capability. So it's sort of an interesting way where you take open source software that was designed to address a core need, and then you track it along as it becomes more mature and you find soft spots in the implementation. And then you also build around it a way to offer that as a service as part of a coherent offering to corporate clients as part of that. So then, just for fun, this is the end of the high gloss part. These are the folks that end up using our services. And you leave you for a minute to look at those. I mean, there's a variety of places, because we offer such a diversified set of infrastructure or these layers that you can access, we end up having a lot of different customers that come at us different ways. So, you know, these are the, say, online catalogs. These are the content delivery network subscribers. You end up, you know, the streaming media is down here. Because we're SAS 70, you know, we can have data centers that will allow you to satisfy your HIPAA requirements. There's a lot of interesting, and actually a lot of other folks that are in seemingly competitive spaces are also our customers. Okay, so in other words, it does also indicate our openness to engage other enterprises or customers at whatever sort of service they want to outsource. So then you get around to, well, why are we here? I mean, this is Internap. So we're here to try to engage Georgia State sort of on 3 different levels, as has been sort of mentioned. We have internship programs that are paid internship programs with, you know, and of course, Stuart would know, I think we can even do internship programs that maybe count for credit. If an arrangement was done in a certain kind of fashion so that the professors are confident of the work or whatever the problem statement, you know, would be worth credits. Now, of course, the more straightforward thing is we're here to hire. We have hire tickets. We're growing, right? We're being successful as a software engineering group, and we have hire tickets. There again, Stuart knows more about that than any of us, but we're often brought in to interview, and I know we have some open racks. And to me, I think the long-term most interesting thing is to develop joint research. What are the areas of research that you guys are thinking about and spending time working on that you could either apply to our domain, that you could use our resources in order to help you achieve your results. Those resources might be in terms of experimental data or actual data. It might be in terms of facilities. We've talked about, Bobby has indicated that, you know, we have clouds, we have lots of machines, we have clusters of various sorts of compute nodes. So it may be the case that we want to do some work in that fashion. I don't know if any of you guys look at Planet Lab or some of the sort of the analysis of the internet as a whole. I mean, that's an area that now the artifacts we've created over the last 20 years are now subject to study. Okay, you know, we did all these protocols, we built all these systems, we wired them all together. Now it's almost something that is deserving of study itself. You know, how information flows and such. So along those lines, we sort of we broke up the task of saying what is it that we're interested in. And now this is where I'd really like to. Everybody's almost finished eating their lunch. They're thinking about it. Let's think about and maybe even have this open discussion on some of these areas. If any of these are sort of like high-level areas that we might want to address in a variety of granularities. So, since Anna is here, we put her slide first. But there's a lot of stuff. If you're really talking about trying to understand the quality of some software that you have constructed, some things become really relevant that you might not have thought of if you were doing a project to turn in at the end of the semester. And one of those, of course, if you're grading a bunch of papers, you might want to think about this. It might be interesting to have automated methods of validating whether or not some requirements were satisfied. In that sense, you can think of a homework assignment or a project as a set of requirements, and that these submissions, what do they rate? How do they score? Right. And it would even be better to have some really solid basis, mathematical, scientific basis for that validation. So, and we end up having complex systems with a variety of components that interact in somewhat involved ways.